Hello, I am Professor Rathod. Today I am going to deliver on the topic of topping cycle. Topping cycle comes under the subject of applied thermodynamics under the power plants. Now, what is a topping cycle? Actually, this topping cycle comes under the concept of cogeneration. Now, basically, what is cogeneration? Cogeneration is the simultaneous generation of electricity and steam or heat in a single plant. So, cogeneration is the simultaneous generation of electricity as well as the steam or heat in a single plant. Now, this is divided in two types. One is topping cycle and another one is bottoming cycle. Now first we will see what is topping cycle. So in this diagram of the topping cycle, so what is the diagram of topping cycle consists of? Now the cogeneration of plant with back pressure, which you can see in the right to the in this diagram. In this diagram, the main parts or the main equipment consists are boiler. Now the turbine used is back pressure turbine, and process heater, then pump. So these are the four main equipments which includes in the generation plant with the back pressure turbine of the topping cycle. So how it works actually, topping cycle, in this cycle primary heat at the higher temperature end of the Rankine cycle is used to generate high pressure and generate high temperature steam and electricity in the usual manner. So you can able to get it from the topping cycle. In this cycle we can able to get generation of high pressure steam as well as the electricity, and that is the concept of the cogeneration. Now in this cycle how it process? In this cycle the process at the low pressure and low temperature is then taken from the turbine as per the process requirement. Now there are two ways in which the steam is utilized. So they are, now the one that is also called as A, by using the steam at the turbine exhaust. The steam turbine in this case is called back pressure turbine. The turbine used in this topping cycle is back pressure turbine. The turbine, we know the turbine which actually which is connected to the generator, and generator generates the electricity on the strength of the steam that the turbine works. Now why it is called as back pressure turbine? By using the steam at the turbine exhaust, the steam turbine in this case is called back pressure turbine. What it is important in this is, what is back pressure turbine? Just now as I want to explain, the condenser is removed and turbine exhaust is led to the process plant. Since the condenser is absent in the exhaust, pressure of the turbine is more and its efficiency is lower, and that shows in the figure that is called as figure A. Figure A shows the flow diagram of this type, which consists of boiler, back pressure turbine. The turbine is again connected to the generator, and then process heater, and then pump. So these are the four main equipments what is there in the topping cycle. Now the next part of this topping cycle is figure B, which shows the cogeneration plant with extraction turbine. In diagram A, we have learned what is back pressure turbine, how it works in the topping cycle. Now in this diagram, we have to learn what is the extraction turbine. So in this diagram, in this figure B, so again there are boiler, turbine, condenser, pump, and in between that the turbine and the pump there is process heater. Process heater is there. So how it works? the by extracting a steam from the turbine at the intermediate stage, much as for a feed water heating, the turbine in this type is known as extraction turbine, or also called as pass out turbine. This pass out turbine is shown by this label. This turbine which is connected with the generator, that generator which generates the electricity. Now why it is called as extraction turbine? By extracting a steam from the turbine at the intermediate stage, much as for the feed water heating, the turbine of this type is known as pass out turbine or extraction turbine. Since the condenser is used, the efficiency of cycle is higher and steam extracted has a much higher pressure and higher temperature. Now this figure B shows the flow diagram of this type. Now the diagram TS, that T is the temperature, S is the entropy. What it shows, the triangle which shows the saturation curve, the significance of the saturation curve, top of the point is critical point, this top of the point is the critical point, left side of that dome is saturated liquid region, and right side of this diagram is a vapor region. Now we will understand this meaning of this TS diagram with help of the schematic diagram of this cogeneration plant with extraction turbine from 1 to 2. What is there in between 1 to 2? In between 1 to 2 there is one of the equipment which is called as pass out turbine, or also called as extraction turbine. What is extraction turbine? We have learned just now. So what happens in that? There is expansion of the steam is happening inside the turbine. It means the expansion is taking place, means the temperature decreases from point 1 to 2, just you can see in this diagram, right? Then what happens in from 2 to 3? So in between 2 to 3 there is again the equipment is pass out turbine, that is turbine. In the turbine, when the steam goes and falls on the blades of the turbine rotates, then there is the expansion happen, then again there is a temperature decreases. So from, if you see from 1 to 3 there is decrease in the temperature, by the same time the entropy remains constant. It means this process is called as isentropic process. Then from next from 3 to 4, what happens in the 3 to 4? What is the equipment in between 3 to 4? That is a condenser. Whereas in this diagram the condenser is there. In the diagram A there was process heater. Now what happens in the condenser? The condenser from 3 to 4, the temperature remains constant, but there is a decrease in entropy, as you can see in the line of 3 to 4. So next in between 4 to 5, what is the equipment between 4 to 5? That is the pump, or also called as water pump. What happens when the pump pumps the water? By that time there is again increase in temperature. If you can see in this diagram of the TS diagram, the temperature increases and little bit the entropy remains constant. So that happens in the water pump. Then next is what is there between 5 to 6? What is there? If you can see this diagram, this is point number 5 and this one is point number 6. So then 5 to 7, if we see in this diagram, what happens? The temperature as well as the entropy increases and it goes up to 0.7 and little above of the 0.7. Then again the temperature remains constant and entropy increases and it goes above the saturation temperature, means it goes to the superheated condition at point 1. So what is the importance of it? What is the importance of it? The topping cycle is basically used to generate the mechanical energy as well as the thermal energy, whereas the topping cycle is concerned, first we generate the mechanical energy and then the thermal energy is produced, and that is the importance of topping cycle. So what it is important in the topping cycle? Topping cycle can be explained on the basis of the two of the diagram. One diagram is cogeneration plant with back pressure turbine, and another one is cogeneration plant with extraction turbine. So the big difference between the two of the diagrams is back pressure turbine, which is there in the diagram A, that is the above the condenser, and 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 in the diagram B, the extraction turbine, which one is connected in between process heater and the condenser. Then the pump is again connected to the boiler, then the pump supplies the water to that boiler, and like how this cogeneration plant with extraction is works. Now the main advantage of this cycle is its ability to use the wide range of fuels including wood, coal, petroleum, coke, etc., and hence used where the low quality and byproduct fuels are readily available. However, this type seldom, that is a very few times it is used, very few it can be used, that is nothing but the word seldom, because of its high initial cost and low pressure to heat ratio, especially at high process steam pressures. So this cycle has having the advantage as I explained now. So this is all about the topping cycle. Mainly in the topping cycle, first the mechanical energy is produced. So mechanical energy, what is mechanical energy? When the turbine rotates, it means the mechanical operation is happens, that is nothing but the mechanical energy. So with help of that turbine, there is the generator is attached, and so that the electricity can be produced. And then thermal, it means what? When we supply the heat to that boiler, it produces steam, that is nothing but thermal energy. So that is how the topping cycle is advisable. That's all. Okay, thank you.